Hey everybody, it's Mr. C, and I'd like to illustrate why the absolute value inequality involving the great Tor symbol splits up into the OR compound inequality. And I'm going to make reference to an absolute value inequality I solved in a previous video, where it was the absolute value of x is less than 3. We saw that answers for x need to have a distance away from 0 that are less than 3 units, and when we graph those, we saw that those answers for x would be strictly between -3 and +3 on the number line, because any value from this shaded region would have a distance away from 0 that's less than 3 units. Well, now I'm going to go ahead and flip the script and solve a similar inequality, the absolute value of x. I'll also tie in 3, but I'm going to reverse the direction of the inequality symbol so that it now turns into the great Tor absolute value inequality. And like the other video, I'm going to go ahead and make a graphical argument for why this breaks up into the OR compound inequality. So on this number line, I'm going to place 0, of course, and also -3 and +3. So by having the inequality symbol reversed for this problem, in other words, absolute value of x is greater than 3, it greatly changes the logic. We now want values of x, or numbers, that have a distance away from 0 that's larger than 3 units. So any numbers that are between -3 and +3, they're clearly not going to work, because say for instance we sampled x equals 1, 1 has a distance away from 0 that's less than 3 units. Okay, so there's actually not going to be any shading between -3 and +3 for something like this. In fact, let's think about maybe an answer for x that's positive that would have a distance away from 0 being greater than 3 units. Can you come up with one? Maybe x equals 4, right? And of course 4 is to the right of 3 on the number line, but even more importantly, 4 has a distance away from 0 that's greater than 3 units. And it quickly generalizes, and I'm going to go ahead and shade the part of the number line that's to the right of 3, basically saying that any answer or value of x that comes from this shaded region is going to have a distance away from 0 that's greater than 3 units. All right, now again, looking back at the inequality symbol, it is not involving the bar underneath it. So for that reason, I'm going to put a parenthesis on the 3 on the number line, and of course pointing in the direction of the shading. All right, so here's one portion of our answer. Okay, answers for x that have a distance away from 0 greater than 3 could be values, to the right of 3 on the number line. But we can't forget about those numbers that are negative that also have a distance away from 0 that's greater than 3 units. All right, and those numbers would be those that fall to the left of -3. And again, for similar reasons, I'll go ahead and put a parenthesis on the -3. But if you think about it, a number from this part of the number line could be something like -4, in which case, -4 is greater than 3 units away from 0. All right, and even if you go to plug -4 into the absolute value inequality, you'd wind up taking the absolute value of -4, which is +4, and of course +4 is greater than 3. All right, so we can't forget about the numbers that are negative that are more than 3 units away from 0. Now I'll go ahead and make the connection between why or how the absolute value of an expression u greater than some positive number a breaks up into the OR compound inequality. All right, let's look at the number line again. Because there are two different sections of this number line shaded, there are two different inequalities that we could represent these parts of the number line with. For example, this first part of the number line that's shaded, we could say that x is less than -3. All right, so to have that shaded means this inequality, x is less than -3. Or we could get answers for x, or write an inequality for these answers of x that are to the right of +3 on the number line. And the inequality that would correspond to the shading of the number line would be x is greater than +3. All right, so you'll notice it's kind of written in a different order than what's presented in the table, But that's okay. If we really wanted to force how things are written in the table, we could always rewrite this to say that x is greater than 3 or x is less than negative 3. All right, so going back to the table, we are working with the third row. Our example would be the absolute value of x is greater than 3, of course, and if we were to just jump straight into the rewrite of it, we would say that x is greater than 3 or x is less than negative 3, which that's exactly what we got. All right, so that's an explanation as to why the absolute value inequality involving greater breaks up into the or compound inequality. I hope you found that helpful. Let me know if you have any questions. Otherwise, thanks again for watching.